In order to find the minimum force P that will cause the crate having the weight of 150 pounds to move, whereas the coefficient of static friction between the crate and the floor is given to us as zero point 0.5, we can start by first developing the free body diagram and listing down all the loads acting on it. So I have a horizontal force of P acting at a distance of 3 feet from the floor going towards the left, whereas the weight of the crate will act vertically downward at the centroid of the crate shown in the figure. Since the force is going to push it towards the left, there will be a frictional force involved that is resisting the motion going towards the right given by our variable f. Next, I have a normal that is acting vertically upward. In this case, we don't know the location of normal yet. So let's place a variable x that is measured from the centroid of our crate. Next, let's go ahead and apply our equilibrium equation, starting with summation of forces acting along the horizontal x-axis equals to 0. In this case, I just have two forces, one going towards the right and the other towards the left, so they are equals to one another. Next, I can apply summation of forces acting along the y direction equals to 0. In this case, our normal force is coming equals to 150 pounds. Finally, our third equilibrium equation can be applied at the location where normal is acting, that is at point O. So doing the summation of moment at point O equals to 0 by force P is going to create our counterclockwise moment with a moment arm of 3, whereas the weight 150 is going to create our clockwise moment with a moment arm of x as shown in the figure. Now force F and N won't create any moment because they are passing through the point O. Next, let's assume that our crate is going to slide. If we have made the assumption, we can write an equation of force is equals to mu times n. Just keep in mind this assumption is only applicable whenever the crate slides. Solving, we get our value of force equals to 75 pounds. Since our equation 1 that T is equals to F, so the external load needs to move the crate is given as 75 pounds. Now we have to verify either our assumption was correct or incorrect. So to do that, let's go ahead and apply the value of P in our equation 3P minus 150x and solve for x. Once we solve, we are getting the value of x equals to 1.5 feet, which is greater than the width of the half of the crate. So since our x is greater than 1 feet, our initial assumption that the sliding phenomena is going to take was wrong. So since our assumption of sliding is incorrect, the actual phenomena will be tip over. Now, since it is going to tip over, the normal will act at the very extreme of the crate and our value of x will be equals to 1 foot. Now, let's go ahead and plug that value back in our expression of 3 times p minus 150x and solve for the minimum force required for this thing to tip over. For simplifying, we are getting the value of p equals to 50 pounds.